There are two different parts of the drone surveys that we take when we're doing mapping and modeling. One is the drone and the other is the GNSS system, which is super high precision GPS. We use an RTK or real-time kinematic system, which allows a base station to correct another GPS unit called a rover. As we place the rover on known points throughout the area, like the corner of this concrete abutment or a piece of steel beam over there, when they won't move, we can actually use that precision GPS location to stitch together the photos in a more accurate way. It allows us to create measurable maps and models that are typically within 3 centimeters of accurate to reality. With the drone here, first flight we're going to take is with a Dji Phantom 4 Pro. This is a 20 megapixel camera on an automated flight path that's going to fly at about 120 feet above these trees and take a series of 300 photos for this 3-acre plot. Those get stitched together to create a flat orthomosaic map. And then we'll use that map as a base to add in 3D models taken from a different drone that we'll play with a little bit later. So as we go, I'm doing my pre-flight checklist, making sure that my area is clear, following all the different safety guidelines, and doing a pre-flight checklist. So what we're doing with the drone is we're flying a double grid pattern where we fly at about 126 feet. And we're going to fly an 83% forward overlap and an 80% side overlap in order to get those pictures to mesh together as well as possible. We're also flying a double grid with a 45-degree angle change, so that'll allow us to get different angles of the objects that we're shooting straight down on, which allows for a better reconstruction of the map and the model. The value proposition is there for architects, for engineers, interior designers, basically anybody who wants to take something that they can't be there, right? They can't be present, whether it's due to COVID or whether it's due to distance. I've had clients who are the investors for construction projects or development projects where they can't come, right? Right now they can't fly from California or Washington or wherever they're investing from. And so I go out with the drones and I build these highly immersive 3D models that allow them to click through on their desktop and go to each location, see the facades, see what entryways look like, parking, make sure that everything is being kind of built properly, right? As the technology progresses, it goes from this really pretty thing that they can come and look at and see, hey, we're doing a great job, to being a measurable, actionable model. If you can click, one corner of a house and click the other corner of the house and get an absolutely precise measurement of the frame that they've built, you can actually compare it to plans. You can do as-builds, and you can determine whether or not the project is progressing the proper way. Using ground control points and a drone like this for this type of orthographic map, we get what's called, you have the ground control or the ground sampling distance, GSD. Ground sampling distance is the amount of space that's in a single pixel in the photo that's generated at the end. So if your single pixel is 1 inch, then the highest possible accuracy you could get is 1 inch. However, on the X and the Y, on your horizontal axis, typically your accuracy is 1 to 2 times your ground sampling distance, so it'd be 1 to 2 inches. On the vertical axis, the Z-axis, you're going to be talking 2 to 3 inches of accuracy, or 2 to 3 times the ground sampling distance, which is 2 to 3 inches. I like to fly very, very low, and that's one of the reasons that I use a Skydio drone, because the obstacle avoidance is really exceptional. And I fly very, very close to buildings. The last scan that I did, I was within 6 feet of the facade of the building the entire time, which allowed me to generate what I call a surface sampling distance, since it's not the ground. Surface sampling distance was less than 1/10 of an inch. which is the smallest that the software would measure. So somewhere under 1/10 of an inch, which means your accuracy is between 1 and 3/10 of an inch, which is pretty good. Based on my model measurements, I use a laser tape measure to take checkpoints to figure out exactly how accurate my model is, and then I check it against the model after it's complete. The Troy Castle, that model that I just built, was precisely accurate on all of my checkpoints, 100%. There was no margin of error at all, which is kind of cool. So one of the interesting things that I'm currently working on is a way to generate a 3D model of a forested area like this, where we actually take the high angle photos from the drone that's in the air right now, and we combine it together with low angle, we'll call them oblique photos, from inside this forested area. By building that 3D map, we can actually cut the tops right off of the trees. So one of the things that surveyors worry about is any tree that's greater than 8 inches in diameter, because architects and engineers need to know that during the design and construction phase. If we're able to chop the trees off just above the ground line, we actually will get perfect, round, measurable model of each one of those individual trees. So you can go right in there and AI will select any tree that's greater than 8-inch diameter, highlight it, and let the surveyor know that here's where the precise GPS locations are for all of these trees. That's new. That's something that nobody is doing. And it's going to be really useful, obviously, for surveying, but also for forestry. If we can automate the process and have it actually go out, fly over the forest stockpiles, cut all the trees in half, and get a precise count of the number of trees that are out there, we can save what ends up being a 5 to 10% variation on a lot of forestry estimations. So you can tell, hey, I'm 5% down, I'm 5% up, and I'm able to get a better, much more accurate count than you would just by guessing. Mm-hmm. So the reason that I use the DJI drone initially for the orthomosaic mapping is because it has a higher caliber camera in it. It's a 20 megapixel camera. It allows us to maintain the same ground sampling distance but flying at a higher altitude. When we have trees like this, we don't want to fly a low altitude because obstacle avoidance may or may not pick up on things like small branches, and you could have a crash, which is obviously not something you want to deal with. Part of my process also involves walking the perimeter of buildings like this with a mirrorless camera at the beginning of the shoot and taking shots that would be conducive to normal terrestrial photogrammetry, because when you're flying a drone, your worst shots are going to be the ones closest to the ground. Because no matter what, you're really not going to be able to get perfect angles. You're going to end up being, at least a couple feet off the ground to shoot the foundation and the edges and all that. The next step after flying this drone is that we're going to take the other drone, which is a Skydio 2, and we're going to fly low oblique images right around the buildings and the other structures that are here in order to generate photos for a 3D model. Because this drone actually has built into it is an autonomy engine. It uses the same type of technology that Tesla uses in its self-driving cars. And as it's flying, it's got 6 cameras. There's 3 on the top, 3 on the bottom, that generate a 360-degree view around the camera. around the drone and allow it to build a live 3D model as it's flying. It's absolutely amazing. And so this is a hand launch for this one today.